76. A unity feedback control system is shown in the figure below. The range of k for which this system is stable must nearly what number? A, B, C, D. When this question is talk about the control system, stable, we can find the information in the page 112. They have the loss test. Here, the necessary and sufficient conditions for all the rooters of the equation to have negative real parts. Negative real parts means stable. The existence is stable. Is that all the elements in the first column be of the same signs and non-zero. It means in here, AM minus 1, B1, C1, all these current elements should be the same signs, positive or negative. No signs changes. If it's positive, all the positive. If it's negative, all are negatives. So we know the condition. So for now, we need to find what the characteristic of this control system. For this one, so we have the formula, we have the definition here in this classical negative feedback control system model. So we just follow this model. You see, we can use this is called GS. Here we can call the HS. So CS divided by RS is equal to what's this? G1 just GS. GS and 1 plus GS times HS. We know HS is the unit equal to 1. So we can put the formula here inside. This is S cubical plus 4S square plus 6S plus 8. This is K. And here is 1 plus GS, this one. So S cubical plus 4S square plus 6S plus 8. This is K. We just simplify times this one, and then we can cancel this. Get this one. See, this is S cubical 4S square plus 6S plus 8. This is S square plus 4S 6S plus 8 plus K. This is the same. S cubical plus 4S square plus 6S plus 8. This is K. We know this is the same. We can cancel each other. Cancel. So can get the number is S cubical plus 4S square plus 6S plus 8 plus K. And the K. So this is the characteristic equation. So this is S3 plus 4S square plus 6S plus 8 plus K equal to 0. Equal to 0. So we can use the loss test formula here. This one, A, you see this in this equation, the highest row odd m is equal to 3, right? N is equal to 3. So A A3, use this one, A3 m minus 2 is A1. So this is the first one is m A3 A1 is equal to what number? A3 should be equal to, oh, A3 should be equal to 1, right? The first rules, this 1 and 1 is 6. Should be A3, A1, like this. A1 is equal to 1. This is 1. A3 is this one. A1 is 6. 6. This is A2. A0. Which one? A2 is 4. A2 is 4 here. 3, 2, 1, 0, right? A0 is this one, 8 plus K. 8 plus K. How about the B1? Is B1 here? Is B1 equal what number? A3 minus 1 is A2. It's A2. This is A3 minus 1 is 2. 3 minus 1 is A1. So A2, A1. This is A3 minus A3. This is M minus 3. So A0 should be equal to A2 is which one? A2 is 4. A2 times A1. A2, A1 is 4 times 6 minus A3. A3 is 1 times A0. 8 plus K. How about C1? C1 here. C1, because this is A M minus 3. A M minus 3, 3 minus 3 is A0. This is B2. B2 is equal to 0. We have no B2. Because the B2 is A3, no M3, because the maximum is number 3. So there's no B2. So B2 is 0. So B1, AM, this B1 minus divided by D1, we cancel the B1. So C1 is equal to AN minus 3, equal to A0. C1 is A0. What is A0? A0 is 8 plus K. So you see in this column, 1, 2, 3, 4. Oh, this is 1, this is 4, the positive. So this one should be positive. This one should be positive. If all condition is satisfied, so this system will be stable. So this one should be greater than 0. This one should be greater than 0. So from here, move this 4 out. 24, move this one out, this 8. So K is less than 24 minus 8 is 16. So from this one. From here, K is greater than minus 8. So the range for the K should be K less than 16, greater than minus 8. Minus 8. So we can check the answer. The answer should be C, right? Minus 8 less than 16 is C. Should be C. Correct answer.